So today we want to solve a question on wave-particle paradox. All right, here goes the question. A photon of wavelength 6.0 times 10 raised power minus 7 meters behaves like a particle of a certain mass. The value of that mass is Planck constant H is given as 6.63 times 10 raised to power minus 34 joules second, and C is given as 3 times 10 raised to power 8 meter per second. Let's bring out what is given in the question. Our wavelength, which we use lambda to represent our wavelength, 6.0 times 10 raised to power minus 7 meters. Then my Planck constant H is given as 6.63 times 10 raised to power minus 34 joules second. Then my speed of light C, or velocity of light, is 3 times 10 raised to power 8 meter per second. First thing is that recall that the energy of a photon is given as what? One of the famous physics equation, change in mass, which is mc square, right? This is the equation, one of the equation for the energy of a photon, right? Now let's call this equation 1. Also, this same energy can be expressed as E equal to Planck constant times the frequency, right? From velocity, which is speed, is equal to what? Frequency lambda, right? Now if I make frequency the subject, I'll divide both sides by lambda, divide both sides by this, right? So my frequency is equal to what? C over lambda, right? Good. So if I carry everything here like this, I replace it with this F, what am I going to have? Here I'm going to have F C over lambda. Good. This is my equation 2, right? Now compare equation 1 and equation 2. Equation 1 is energy, equation 2 is also energy. That simply means mc square is the same thing as hc over lambda. Good. So what I'm going to have is mc square is equal to hc over lambda. Good. I'm asked to calculate my mass, right? Let me see what is going to cancel out. C will cancel 1c. What do I have remaining? mc equal to h over lambda. Still not satisfied. I need to make m to stand alone. So I'll divide both sides by c. So c here, right? That means I'm going to have times 1 over this, right? Good. C will cancel C. So my M is equal to H over C lambda. This is what I am going to use to get my final answer. I will substitute my values here, right? Good. Now, before we get our final answer, please, if you have not subscribed to the channel or follow the Facebook page wherever you're watching from, do well to subscribe to the channel, follow the Facebook page, share with family and friends. Thank you. Let's go there. Good. So my mass now, my Planck constant is given in the question as what? 6.63 times 10 raised to power 34. So I have 6.63 times 10 raised to power minus 34. Good. Over my C is 3 times 10 raised to power 8 times my lambda. My lambda is given as 6.0 times 10 raised to power minus 7. Good, right? Now I'll simplify it. What I have here, 6.63 times 10 raised to power minus 34 divided by, apply simple of indices. 3 times 6 will give me 18 times. Now when I'm multiplying, when I have the same base multiplying each other, what I'm going to do is 8 minus 7, which is supposed to be 8 plus minus 7. So what I'm going to have is times 10 raised to power 1, right? If I apply law of indices here. Good. The next thing is I can still apply law of indices. I can divide this one here, then subtract the power of minus 34 minus 1. I will still get the same answer, right? If I divide this, I'm going to have 0.36833 with some number like that. Good. So these aspects, what am I going to do with them? I'm going to have times 10 raised power minus 34 minus 1, right? Based on law of indices. Good. So next I'm going to have is 0.3683 times 10 raised to power minus 34 minus 1 will give me minus 35, right? Good. So if you look at the option, I don't have anything like 0.3. That means I will need to change it to standard form, which I'm going to have 3.68 times 10 raised to power minus 36, and you look at it, the closest to it is this, which is the correct option, right? Thank you. Bye.